Hello guys, so in the previous video I have discussed about how to install NumPy and how to create an array. In this video I'll be talking about attributes and functions of an array. So attribute is a specification that defines the property of an object. Attributes of the NumPy array do not have the parentheses following them. So they do not have parentheses after uh, following with that. So and dimension returns the how what is the dimension of an array. So over here let's understand with the code. So np is the alias which is given to numpy, port numpy as np. So np is alias, and inside that we have an array function, and the function we have passed an array with two tuples inside, so 11 32 23 and 34 55 46. So this will be uh, passed inside one array, and it since it's an array, so it's a 2D array, so n dimension will be 2. So now we'll understand about the item size function. So item size will find the space occupied by each element. So np dot array 56275 3, and since it is an integer element, so it occupies 64 bits of memory, and 64 divided by 8, so it will be 8 will be the item size of this. In the above example, every bit occupies 4 bytes, so it will be 4 into 2, it will be 8. So dtypes use dtype function to print the data type along with the size in the bytes. So dtype will print the size of the bytes. So we have created one array. So dtype it will tell it's a int 64 machine. So the data type is integer. Size and shape. So use the size to find the number of elements in an array, and shape to find the numbers of rows and columns in the array. So first we'll create an array, and then we'll see size and shape. So size, if you'll see, size is 1 2 3 4 5 6. 6 elements are there, so it will tell the number of element, and shape will tell what is the number of rows. So number of row is 1 and number of columns will be 6. Moving on to function methods. A method is a function that belongs to an object. It takes the parenthesis in the parenthesis and returns the modified array. So first we'll create an array. So we have created an array. Now we'll say this is an original array. Now we have to what we have to do first is we have to reshape. So reshape shape is used to change the number of rows and columns of an array without changing the data. So without changing the data, I have to change the number of rows and columns of an array. So I don't have to change that. So let's see reshape. So I'm saying make the array with 3 rows and 2 columns. So now we'll print the reshaped array. So as you can see, it's a 2D array. So 8, 9, 10, 11, 12, 13, it's the original array. And now we have to reshape it. So we have to reshape into 3 rows. So 8, 9 is the first row, 10, 11 is the second row, and 12, 13 is the third row. And in this we have elements 8, 10, 12 is the first column, 9, 11, 13 is the second column. So this is the reshaped array. Now we learn about indexing. indexing in one dimension. So for one dimension, let's see, this is the given array and we'll print that array. So 11, 12, 13, 24, 57, 473 is a given array. And now we have to access each element by passing the position of index of the element. So if we'll say my array 0, it will return 11. And if we'll say my array 2, so it will count 0, 1, 2, and this will return 33. So let's run the code. So see, first 0th index is 11 and second index is 33. So index will start from 0, 1, 2, 3, 4, 5. Let's suppose I say it's 5. So this will give me 473 element. Now we'll see indexing in 2D. So now we have learned about 1D. So we should learn about 2D. So this is a 2D array. This is a 2D array. So let's and we'll print my array. We can review the elements of a 2D array using the two indexes. So I have to pass ith and jth. Uh, I I will select the rows and j will select the columns. So if I'll say select the first row, so I have to say I0 and column is also 0. So 4 1 12 will be printed. Let's go to that and we'll say print my array 2 1. So it will go to 0 1 2. 2 is this and then column 0th column 1th column. So 821 will be printed. So this will get the element in the third row and the second column. So this will 821 will is printed. We can pass the ith row and jth column in the separate bracket also. So if suppose I don't want to pass in the same bracket. So in that case I have to take the separate bracket and then I'll pass the index of it. So in this case it's 2 and 1. So it will go to the third row and it will select the second element. So this will print the 821 for us. So picking a row or a column. So let's see. We can also select a single row or a column. So how to select a single row from the array? So we just have to pass the row number. We don't have to pass the column number. So it will go and say it's a second row. It's a third row. So it will take those elements and print them. So let's see, this is the first row, this is second row, third row. So since indexing starts from 0, it will I have to pass for the third row is 2. So 712, this will be printed. Now I have to pick the second column from the array. So if I have to pick the second column, so let it be any row. I don't have to bother about that. I just have to print the column. So I'll give the column there and let it be anything. And then I'll print the second column from the array. So this will be printed. Now we'll learn about slicing. So that is our fifth topic in the NumPy array. So slicing a 1D array. So my array, this is the array 101, 121, 112, 123, 114. Now I have to slice. So what I have to do first is pick the second, third and fourth element from the array. So first element will be 121 and second will be 112, third will be 11123. So we have to take second, third, fourth element. So I'll pass it as 0 1 1 this and uh, 1 2 3, so plus 1, so I'll pass n plus 1, so 1 is to 4, so it will print 121, 112, and 123, and 123. That's it. It won't print 114. Now moving on to slice notation. So specifies a start and end value. So what is the start value and the end value? Where start is exclusive but end is inclusive. So start, we should not bother about whatever is start, it will take the start, but it will remove the end element. So if you say it's taking first element, so 0 1, it's taking 121, it's going 112, it will print 123, since it is a third element itself, but it won't print fourth element, it will print only till 123. So that's what it says. The slice notation specifies the start and end, where start is inclusive, start is we have to consider, end is inclusive, end we should not consider. So first three element, so it will take 101, 121, and 112, it will print that. Now if I have to print all the element from 112, so 112, as you know, 012, it's a second element, so second column, print entire, it will print that. Now get the complete array, don't pass anything, just give a colon, it will get the complete array. Now we'll learn about slicing a 2D array. So this is a np.array. Inside that I have passed first array, then second array, third array, fourth array, and I'll keep my array. So array is printed. Now what I have to learn in this is I have to select all the row except first and select the third and fourth column. So please uh, first row, all row except first, so this I should not take, so I'll give 1 from 1 start, and then select third and fourth column. So now I have to give the column indexes, so third, this is the first, second, third, so that is 2 0 1 2 till 4 3 and 4, so it will print that. Now we'll learn about operation on 1D array. So let's see my array 2. Okay, so first array is this array where we have written 122, 230, 310, 412, 150, this one. And the second one I have said take till 5, so it will I haven't said that take from 0 till 5, I have said just take 5 elements, so arrange 5, so 0 1 2 3 4. If I'll say till 10, so it will print till 9. Now अब क्या करना है, we have to add the two array. So first array is my array 1 plus my array 2. So my array 1 plus my array 2. So what it will do, it will add the two array and So let's, since why it is giving an error, because I am saying it's a 5 elements are there in the first array and 5 only should be there in the second array. So element size should match. Now if I'll run, it will add 120 plus 0 will be 120 itself, and 230 plus 1 is 231, 310 plus 2 is 312, and 410 plus 2 is 413, and 150 plus 4 is 154. So adding two array is possible. Now I have done my array 4 also. I have 1, 2, 3, 5. Now first array plus this. Again here it is saying, what it is saying is 1, 2, 3, there are only 5 elements. Only 5 element size should be same, but we are saying add different, so it will give that error. If you have to omit the error, you have to pass the same size of an array, same element in the array. So now it will add. So if you try to add the array with same dimension but different number of element, you will get the error. So same number of elements should be there for addition. So multiply each array element by 4. So my array 1 into 4. So it will multiply by 4. So for squaring we should use double asterisk for squaring. So it will square each elements. So using NumPy with comparison expression. So now we have to compare each element. So we have to check elements are greater than or equal to 40. So my array greater than or equal to 40, and that comparison condition gives Boolean output, whether it's true or false. So for the first element saying false. For the second element it's saying true because 45 is greater than 40. It's true. Second element 67. This is also true since it is greater than 40. 45 is also true since it is greater than 40. 23 is false since it is less than 40. So this is the comparison operation. Now pass the ever boolean array to give main array to each value that specify the comparison condition. So this is the comparison condition, my new array I have passed in it. So my array will be this one, whichever is the greater element, so that will be stored in this array. So rather than creating a separate array of the boolean, you can specify the comparison operation directly to the main memory. So rather you are comparing and then storing it, so directly you can pass it to the main memory. So my array, I'll print, it will give 35, 45, 67, 45, 23. So it has not changed anything. Now this is the array, and if I'll pass it, if this one, so since we are storing comparing and then we are storing in the true false, so directly we can pass my array itself. In my array we can compare and print. So you can see my array contains 45, 67, 45. So whenever you have to compare each element, you can use this type. Operations on 2D array. तो अब हम क्या करेंगे, let's create two-dimensional array A and array B. So अब दो dimension का array create करेंगे, array A and array B. So when we'll hit shift enter, so two-dimension array is created. So as you can see, 33, 12, 70, 61 is the array A and this is the second array. Now we have to add the two array A plus array B. So two array have been added. Now we have to perform multiplication on array A and array B. So multiply this and you will get this one. So and now moving on to plus and equal to. So add 2 to each element. So array A plus 2 is equal to array A. As you can, this is simply like array A is equal to array A plus 2. 2 will be added to each each element of the array A. So similarly, you can use other arithmetic operands like minus equal to or star equal to. So subtract 2 from each element. So now we have to subtract 2. So this is nothing but array A is equal to array A minus 2. So 35 minus 2 is 31. 14 minus 2 is 35 minus 2 array A. So array A is, oh, this is plus 2. So we should go to original array A. Where is that? Array A. So 33 plus 2 is 35. 10 plus 2 is 33 plus 2 is 12 plus 2 is 40. 70 plus 2 is 72. And 61 plus 2 is 63. So original array plus 2. Similarly, you can use other arithmetic operations like minus equal to or asterisk equal to. This will give the same results, like array A is equal to array A minus 2. Array, when we have to multiply, then we'll say array asterisk equal to 2 means array is equal to array into 2. So that is a array 2. So ampersand at the rate operator is used to perform matrix multiplication or matrix product. So now we have used at the rate. So it will multiply array A into array B. The same output can be obtained by the dot operator also. So for multiplication we can use two operators. One is at the rate and the second is dot operator. Now we'll learn about the third topic, that is arithmetic functions in NumPy. So this is an array and this is the given array, and we have another functions called sum. So sum function add all the value in the array and gives a scalar output. So my array dot sum, so 5 plus 7 plus 8 plus 2 plus 4, so it's 24 is the 26 is the output, sorry, and then min returns the lowest value in the array. So let's see what is the lowest value. As we can see, it's a 2, so it will return 2. So power function raises the number in the array of the given value. So let's check my array to the power np dot power. My array to the raised 3. So 5 is 5 to the raise 3, then 7 to 3. Let's see, this will be the uh, raised to the power of the array. Using the access parameter, so create a 2D array of the random integer. So np.random randint. So we have passed the access with value 0 and find the sum of all in the single column. Okay, so here it will create a 2D array of a random integer. Since we are saying randint, so it will take from 1 till 10 and step size will be 2 to 3. 2 rows and 3 columns. So here you can see is 1 row, 2 row and column is 3. So it will take randomly it will generate a number from 1 to 10, but it will be an integer number and it will be arranged in 2 rows and 3 columns. So that is np.random.randint functions. Array 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 1 dot sum access equal to 0. So it will find the sum of all the columns in the single column. So 8 plus 2 is 10, 7 plus 2 is 9, 7 plus 5 is 12. So 10, 9, 12. It will give in a single column. Similarly, to find the lowest value across a particular row, use the access parameter with value 1. So minimum it will be 1. Now we have to concatenation of an array. Now concatenation is nothing but a joining the array. The array can be concatenated only if they have a same shape except in the dimension corresponding to the access concatenation. So array X np.array 11 22 13. So that is a first array. Array Y is the second array. Now we have to concatenate, means we have to combine. So you can see 11 12 13 is the first array, 23 12 22 is the second array. So it has concatenated, it has joined the two array. You can also concatenate more than two array at once. So array Z, so I can pass array X Y Z, so it will give all 11 12 13 23. 13 is the first array X, then 23 12 23 22 12 is the second array, 23 45 is the third array. It is combined and given the output. Concatenation 2D array. So that is for the 1D array. Now we'll learn about how to concatenate 2D array. So my array np.array 1 2 3 4 5 6. This is the 2D array. Concatenate along the first axis. So by default concatenation is along the axis 0. So first array is concatenated with the second array. So 1 2 3 4 5 6 is the first array, then 1 2 3 4 5 6 is the second array, that is the array first array itself, it has concatenated. Now we have given access equal to 1, so it will concatenate along the one axis along the row wise it will concatenate. So first array is 1 2 3 4 5 6, then second is 1 2 3 4 5 6. Row wise it will concatenate. Concatenation 1D and 2D array. So let's take np dot concatenate array x. My array x is equal to 0, so it will concatenate the array x and array y. So if we have to concatenation of 1D and 2D array is not possible. So we should not concatenate one dimension array with two dimension array, so that will give an error. So as you can see, all the input array must have same number of dimension, but the array at index 0 has one dimension and array at index 2 has two dimension, so this is not possible. So dimension should be same to concatenate. So now we'll learn about stacking. Let's take 1 minute break, then we'll learn about stacking. So let's come back. Stacking can be used to join two or more array along the different axes. So along the different axes, two or more array can be joined. These methods can also be used to create high dimensional array using the lower dimensional array. And NumPy vstack, NumPy hstack, and NumPy concatenation are similar functions to join the array. So let's see, we have created a two array. Now NumPy stack enables you to combine array along the specified axis. We can create a higher dimension using stack. So stack array along the first axis. So array 1, array 2. Now we have to stack on top of another array. So as you can see, we have 1, 2, 3, 7, 8, 9. So 1, 2, 3, 7, 8, 9 and 4, 5, 6, 10, 11, 12. So this is a row wise stacking. So first we have kept 1, 2, 3, then 7, 8, 9, and below that we have used 4, 5, 6 and 10, 11, 12. So this is vertically we have combined, and H stacks will combine it horizontally. So H stack horizontally it will combine. So NumPy V stack enable you to combine vertically. So we will give it will combine vertically. D stack array along with third, it converts the each array as the column of the modified array. So D stack, so it will combine the depth wise along the third axis. So depth wise has combined. Column stack enables you to stack it first array or as a second array. So this is done. Now we have to check the dimension of stacked array. So it's a 2D array. Then block is used to assemble the array from the nested list of block. So this is a block. So 2D matrix using the block A, B, and then C, D. So we have kept on top of each other. Now we have to split the array. So let's learn how to split the array. So first we'll learn what is splitting of an array. So splitting of the array is used to split the array into multiple subarray. It is the opposite of concatenation, which is implemented by function like split, hsplit, and so on. So how will we split the array? We'll learn. So np.arrange 8 will give us the array from 0 to 8. Now np.split array x to So it will break the elements into two parts. So 0, 1, 2, 3 is the first four elements, and 4, 5, 6, 7 is the second element. So it will break the elements in equal parts. Now we'll say the split occurs at 5th and 7th indexes. So we'll give np.split array, will pass the array, and we'll say 5th indexes and 7th indexes. So 5th 0, 1, 2, 3 is the fourth in third, fourth, fifth. Let's see. So we are saying 0, 1, 2, 3, 4. From the fifth it is breaking, so 5, 6, and then 7th also you break. So 7th also it has broken. So 5th and 7th. So split array X into 3 sub-arrays. So we'll pass 3. So it will break into 3 sub-array. But it's saying that array split does not result into equal division. So it does not divide into equal division. So we should not use 3 in case. Equal length, it's unable to divide. So we should not use that. So it's saying array split is used to split the array into subarray. It takes integer n as the input of number of split, even if n does not divide into array subarray of equal length. So array split we should use. So array split will divide the array into three equal arrays. So since it does not, why we are not able to divide? So 0, 1, 2, 3, 0, 1, 2 is a 3 element. Here also we have 3 elements, but here it was not having 3 elements, so it was unable to divide. Now we are saying 3. So first 3 elements they have divided, but third element is not there, so let it be. Whatever is there you divide. We split the array of length 8 into 3 subarray. The function array split returns 8 mod 3. It will return 2 subarray of size plus 1, and the rest of the size it will return vertical split. The vertical split function is used to split the array into multiple subarray vertically row wise. So till 20th it will generate, and it will give as a 4 rows and 5 columns. So 0, 1, 2, 3, 4 rows and 5 columns. 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, 5. 5 columns. So vertical split is equal to 2. It will vertically it will split. So from here till here it will split. Horizontally it will split it like this. Two. So you can see 0, 1, 4, 5, 8, 9, 12, 13. This is one split and this is the second split. D split is the split is used to split the array into multiple subarray. So this is the array and D split. So it will give multiple subarray. It won't say that this much array, how much ever array is possible, it will give that. Now in the 12th lesson we'll learn how to iterate a NumPy array. So first we'll create np.arrange 12, so it will give 0 to 12. Now for I in np, for I in my array, and print I plus 10. So first element 0 plus 12, 0 plus 10 is 10, then 1 plus 10 is 11. So in that case it will print 10, 11, 12, 13, 14. From the 10 plus 1 it will do. Now we learn how to iterate a two-dimensional array. So create a 2D array. So it will take the elements from 0 to 12, and then it will give 4 rows and 3 columns. So 4 rows and 3 columns, and it will, for I in my array, print I plus 1. So 0 plus 1. So 0 plus 1 is 11. 0 plus 1 is 0 plus 11 is 11. Then 11 plus 1 is 12. 12 plus 1 is 13. So like that uh, it will print. Iterate each elements in two-dimensional array. Use the nested for loop. So for loop also we can use for I in my array, and then for j in I, and print j plus 11. So it will be printed. N-dimensional iterator object. So NumPy provides a multiple iteration object called n-dimensional iteration to iterate the element of an array. So for I in np dot n-dimensional iterate n iter, and for d for dimensional, and iterate for iteration my array, and then I into 5 it will print. So that's all for this video. If you do like the video, please subscribe to my channel, and for more videos please stay tuned. Thank you so much.